All right. Hello, students. Welcome to our discussion on Newton's laws of motion. I am Harsh Kapil. All right. In this chapter, we will discuss about Newton's all the three laws, first, second, third laws, their application. Okay. Certain terms, those are used throughout the chapter. Okay. Free body diagram, that is very important to understand the different forces acting on a body. Okay, what are the pseudo forces, what is inertia, and then we will understand frictions and its applications on different examples to understand the applications of all these three Newton's laws of motions and its forces. Okay, you can also watch my videos on rest and motion kinematics, projectile motion, single body, two body, 2D body motion, 3D body motions that we have already uploaded. All right, so let's start our discussion on Newton's laws of motion. Okay, these are certain institutional information where you can always get in touch with me for personal guidance program. Okay, to just revise the basic, we know what is a force. Okay, it is known as a push or a pull. Okay, if you are pushing a body, that is also a force. If something is being pulled like a rope, or you are pulling a cylinder or a box, that is also a force application. Okay, we give it a symbol F. Okay, and its unit is N, as in Newton, so it's an N, or kilogram meter per second square. Okay, you know it. Okay, now to understand different forces acting on a body in rest or in motion, we draw its free body diagram. What is it? You can see here. In this example, where is a block is put on an inclined surface. Okay, there is a contact force working on it in the upward direction, its own weight working in the downward direction, mg, we know it. Okay, so instead of drawing this block and the surface, we just draw a dot or a point object and then show these two forces the way they are with an arrow pointing towards the direction of the forces, respective forces, and then it becomes a free body diagram. Okay, if there is an acceleration, then we draw it, that also we will see in the upcoming examples. So the object will be represented as a dot or a point, and the force, okay, it will be represented by an arrow. Okay, so this will become a free body diagram. Now let us understand it with more examples. Okay, see here. In this case, on the left hand side, as you can see here in this example, there is a stone, big stone, that is lying on a surface. Okay, there are certain forces acting on it. A applied force that is trying to push it in the rightward direction here. Okay, but it is not moving. That force is not capable of enough to move it in the rightward direction. The surface has friction. Okay, so there would be a frictional force acting in the opposite direction to the force applied on it, that will be in the backward direction. Okay, this one. Now its own weight working in the downward direction. Okay, this one. And the normal force, the contact force, in the upward direction. Okay, so these are all the four forces acting on it, and the body is not in motion. Now in the second case, if you see here, okay, there is a motor boat. Okay, if it is moving in the rightward direction, okay, its machine is pushing it, it is having a force applied in the rightward direction here, okay, as a thrust. Okay, and there would be a drag of the water working at the bottom of the boat. Okay, that would be working in the exactly opposite to the its motion. Now we know the Archimedes principle. There is a buoyancy force instead of contact or normal force. There would be a buoyancy force that will be acting in the upward direction opposite to its own weight, that is working in the downward direction. Okay, so these all forces would be acting on the boat. Okay, so we understood how do we break and understand the total forces acting on a body. Okay, and you can make the free body diagram from here. Okay, now see this case here. These two ladies are trying to push the cart where a child is sitting. Okay, now first lady with black hair is applying an F2 force on the shoulder of the child. Okay, the lady in the brown hair or golden hair is applying a force F1 on the cart. Okay, now there would be a contact force or the normal force acting on both the tires of the cart. However, we will show it as a single force as capital N acting on the cart, overall force, normal force. That is, will be acting in the upward direction opposite to its own weight of the cart and the child together. W to take it. So these all forces would be acting on it. Okay. Now, if you just break it, okay, isolate these forces. Okay, the single object is the son on the cart, the boy on the cart. Normal force upward, weight downward. Okay, pushing force F1 and F2 in the forward direction and the frictional force in the backward direction. These are all the forces acting on a particular object in this. The system and the object is the boy and the cart. Okay, this way we will isolate the forces from the different other objects. Those are acting on the particular object that we are targeting. Now the same case, okay, if we further analyze it, okay, from there if we move here, okay, there is F1 and F2, that means F net, that will be working in the forward direction, weight downward, normal force upward, frictional force in the backward direction. Then it becomes a free body diagram if we reduce further the boy and the car to a point or a dot. Okay, that is the free body diagram, dot and the arrows, nothing else. So dot is our boy in the cart, and the arrows your net forces F1 and F2, forward, frictional backward, normal upward, and the weight downwards. Clear? This way we will be isolating the object, the system that we are targeting, and reducing it to the dot and the arrows. Okay. Another look at the downward side. This picture where the mother is pushing the boy on the cart. Okay, it has an acceleration to say A. Okay, forward force is represented as F adult. Okay, weight is downward W, normal force upward. Okay, frictional force in the backward direction. Okay, if we directly reduce it to the free body diagram, it will become like this: dot, normal force, force by the adult or the mother here in this case, weight of the cart and the boy together, W in the downward direction, and the frictional force in the backward direction. So this way become it the free body diagram. If you are ready with the free body diagram, now it will be simple for you to apply the Newton's laws of motion. How do we apply it? We will see it in our analysis further. First, we will understand what are these three laws. Okay, but free body diagram is the starting of it. Isolate, first identify your system, then isolate the main object on which all the forces are acting, where you need to find out the desired result, and then draw the free body diagram accordingly, and then we will apply the three laws. So let's understand the three laws.